This conference will now be recorded.
So Java, it is basically developed by James Gosselin, Patrick Norton, and three of his team members that are there on the screen. In 1981, it took 18 months to develop this language, the first version of this language, and initially the first version of the language was named Awk, and later it was renamed to Java in 1995. The aim of building this language was to develop a software that can be embedded to various consumer electronic devices such as microwave oven and for remote controls. So I'm not going into detail about the history of this programming language, right? We are directly starting from the concept, how you can create the source file, how you can run the Java program. So on this slide, I have shown that if you want to write a program in Java, then you can use either the Notepad or some other IDE, like you can use Java or you can use Eclipse for the Java programming. So whenever you build a program in Notepad, so first of all you will open it, right? There are many methods to open that you know very well. After opening the Notepad, you will type the Java program. So here is the simple Java program that you can use to print some message on the monitor screen. I'm not going into the details of the Java program. So you will type this program as it is in Notepad, and then you will save it under a file name, and the file name should be same as that of your class name. Although it's not mandatory, later on we will discuss if you give different name to this class then the file name, then what will happen, that we will discuss in the coming slides. So this program you will type in the Notepad and then you will save it under the name. That file name should be the same as that of this name, and the program or file extension name should be .java. So this is the important point. Whenever you write the program in Notepad, you are supposed to save that with the extension .java, right? So after doing this thing, after writing the program, then how you can compile this? For that, you have to switch to the command prompt, and you have to open the command prompt. How you can open the command prompt? For that, you have to type cmd. I'm going to show you how you will compile it. So this is the slide. So when you will switch to the command prompt, this screen will appear on your monitor. This window will appear on your monitor, and this is your system prompt, right? And against this system prompt, you will type the commands to compile a Java program. And how you compile that? First of all, you have to switch to the directory where you have installed your Java, right? And I'm leaving up to you to install Java, right? Because you are the ME students, you can install Java, right? I think you will not face any problem when you will install it. And if anybody finds any error during the installation, he or she can contact me on WhatsApp, or I'm going to share with you the Google. I'm going to create Google Classroom today. I will share the link of that with you as well. So on the Google Classroom, you can leave your doubts. So I'm going to show you how you can compile it. So after opening this, you will open the directory where you have installed the Java. Generally, the Java gets installed under the program files, and then under that there will be a folder Java, and in Java folder there will be a JDK folder, and in JDK there will be one folder named bin. Soon I will show you that on my laptop as well. So when you will open that directory, that Java directory, bin directory, in that directory you will type over here Java C, then the name of the program. If the name of the program is hello.java, then you will type Java C hello.java. For example, over here I have shown this command Java C hello world app.java. So when you will type this command and press the enter key, your program will get compiled. So if there is any error, then the Java compiler will show those errors on the screen. If there is no error, then you will get the system prompt back on the screen. So when the Java program is compiled, a file is created, and that file that is created by the Java compiler is called the class file. So if your program name is hello world app.java, and in this case the compiler, after compiling this file, will create a file, and that file will have extension .class. So here I have shown that. So when you compile the program, you will get this file name hello world app.class. So this is the class file. So whenever we compile a Java program, a class file is created. So this class file is basically the bytecode. It's not the machine language code. Generally, other languages that you have studied already, those languages create the machine code. For example, C or C++. If you compile the C program or C++ program, that gives you the native code. A native code means that can be executed on that machine. So here the Java will not create the native code, it will create the bytecode. It's a specialized type of code. So that is created. So after that you will run this program, Java program. So first you will compile it using Java C at the command prompt. Then you will use Java command to run that program. So you will first type Java, then name of your class file. So keep in mind, I haven't used over here .class. You will just use the name of the file, class file. Name of the class file is hello world app. So you will type Java hello world app, and then you will press the enter key, and after that you will get the message on the screen. So the main important point of these slides are how to compile the program and how to run it. So when you want to compile a program, then you will use Java C, and when you want to run it, then you will use the Java. So this is the first method. If you want to use Notepad as an IDE to write the program, and then you want to compile it using the command prompt. So this is the first method. The second method that I have shown in the slides is using the Eclipse. So you can program in Java using Eclipse IDE as well. So here is the slide for that. So whenever you are using Eclipse, then first of all you have to create a Java project. So when you will go to the file menu, you will get this option over there, and type a sample project name over here, any name of your choice, and then click finish. Then it will create, the Eclipse will create the project. Under a project, you can create many files that we'll discuss in the coming slides as well. So I'm just giving you the overview how to write a program in Eclipse as well. So after this, you will create a class file. Again, this option you will get under the file menu. So when you will click over the file menu option, there will be one option new, and under the new, you will get one option create a Java class. So here I'm going to create the Java class. I have shown one slide over here. So in this dialog box, you will type the name of the program that you want to create. I have named over here example. So type over here the name of the program, and that will be created under the project that we have already created. Then you can click over this to a public static void main if you want. Otherwise you can leave as it is. So if you click it, then the structure that you will get, I will show you in the coming slides. So type over here the name of the file, and then click finish, and it will give you this screen. So in this screen, this is your file that we created earlier. Its name was example. So Java, this Eclipse will already automatically add the extension Java with the name of the file. So in over here, you will type the name, the program, sample program that I have shown you earlier. Right. So here you will type the name of the code, complete code of the program, and then you will compile it by clicking over the icon for executing the program over this icon. And yeah, when you will click this icon, your program will start executing. And the complete execution process we'll discuss in the coming slides in more detail. So this is how you can use the Eclipse interface to run your Java programs, to make source files, to create programs, and to run those programs later on. We'll do this. So this is the process that happens when you create a Java file, a Java program, and as we discussed in the earlier slides, that first of all you will create the file program, and you will name that file as a file with extension name .java. And when you compile it, and then a file is created that is called class file or byte code that gets created, and this byte code file is not the native code, it is basically a specialized code. So that gets created, and then we run the program using Java. And when you run the program, basically your program gets executed in Java virtual machine. It's called JVM. So Java virtual machine runs your program. And I think you know the difference between the virtual machine and the physical machine, right? So if you have any doubt regarding this virtual machines, again you can leave the message on the classroom, Google Classroom, that I'm going to share with you. So this is the process. Java virtual machines runs your program, and you get the output on the monitor screen. So this is the process in more detail. So this is your Java code. You're compiling it with Java C. This is your compiler. If there is no error, you will get the bytecode. And if your name of your program is abc.java, then this compiler will create a class file, and that class file name will be abc.java. And when you run it, what happens? This is shown over here. This box basically represents JVM, Java Virtual Machine, that is responsible for executing your Java program. So when you run Java file using this Java command. So what happens? This your class file gets loaded into the memory using this class loader. So JVM, Java Virtual Machine, has one module, and that module is the class loader. What is the responsibility of this loader? This reads the class file and loads that into the JVM memory. This I will show you in more detail. So after loading the class file in the memory of the JVM, then a bytecode verifiers run on that class file or bytecode. It verifies the bytecode. What kind of verifications it does, we'll discuss that in more detail in the coming lectures. Then your bytecode is interpreted by the interpreter. So Java is basically compiled and interpreted, right? Language. Here in Java, both the processes are performed. Compilation is performed, then the interpretation. We'll discuss it in more detail in the coming lectures as well. So interpreter, you know, it converts one language of your bytecode at a time into the native machine code. So this is responsible for converting the bytecode into the machine code, and then that machine code gets executed on your hardware. And then there is another module, that is the just-in-time compiler. Just-in-time, this JIT stands for just-in-time compiler. In the coming slides, I will explain it in more detail. What is the purpose of JIT, just-in-time compiler? So the next slide is about this. What is the benefit of this JVM? So as we discussed earlier, that when you compile a Java program, a class file or bytecode is created. As Java is basically have one feature that is called portability. So Java is a platform independent language. Platform independence means the Java program can be run on any platform. Here on this slide, I have shown three platforms. This is Windows, the other one is the Linux, and third one is the Mac OS. So the benefit of JVM is for every operating system, the JVM will be different. So this JVM, Java Virtual Machine, is basically Windows based. This JVM is Linux based, and this JVM is Mac OS based. So if you compile a Java program, that gets converted into bytecode, and after that bytecode can be executed on any platform. It can be executed on Windows, can be executed on Mac, or it can be executed on Mac Linux platform. So your Java can be executed on any platform. So that means Java is a platform independent language. But for every platform, this JVM will be different. So this is the benefit of the Java virtual machine. It provides security as well, because your Java programs runs within the Java virtual machine. It can't directly interact with the computer hardware. So if there is any issue with the program, then it cannot, what you can say, it can corrupt your operating system. Can't make changes in your memory, system's memory as well. So this is the more secure programming language. And then comes the shown in this slide the more details of Java virtual machine, what happens basically inside the JVM. As we discussed in the previous slide, this class files are basically get loaded by a class loader. So when it gets loaded into the JVM, so it gets stored over here in the method area. So here the class loader stores your class files. Whatever class you have used, those class files are get loaded in this part of the JVM. Heap is basically to store the variables. If you create any variables in your program, Java program, those variables get stored over here. And in one of the chapters, that is multi-threading, if you are using multi-threading, then this portion of the JVM is used. So, and these two are sections are basically program counter register that you have studied about earlier in machine architecture, and native internal threads. This we'll discuss in more detail. Native internal threads means any other programming language code can be used with Java, with collaboration with Java. We can say if you have one code in C++ and you have another program in Java, we can use that C++ program in the Java, or we can collaborate those two programs, Java and C programs, to perform one task. So these are the native codes. And this garbage collector, again, we will discuss in more detail in classes and objects chapter. Its basic purpose is to deallocate the memory. So basically, this whenever the variable's scope vanishes, this garbage collector deallocate the memory that is allocated for a variable. This is basically the execution engine where your program gets executed, and JIT is the just-in-time compiler to speed up the execution of your program. So this is all about the Java class file. As we discussed earlier, when we compile a program, a class file gets created, and if your program has many classes, we'll start with one class only in the coming slides, but in actual your program can have as many classes as you want. If you are having 5 classes, for example, then your Java will create 5 class files when you will compile it, right? So it depends when you compile the program how many classes you have used in your program, and corresponding to each class, one byte code file or a file with having extension name .class will be created. So the benefit of the JVM we have already discussed, that your program will not affect the system because it will run inside the JVM, and JVM provides the security. It will not allow you to directly interact with the hardware. So this is the main benefit. But the disadvantage is that your program will run slower because every line will be first interpreted, then it will be executed. So it will take a little more time to execute. But this Java is basically optimized, highly optimized language, because it has a just-in-time compiler that compiles the program as and when required to optimize the execution of the process. Again, we'll discuss it in more detail in the coming lectures. What is the purpose of JIT and how it works. So this is the brief introduction about JIT. So the main aim of compiler, you all know, the compiler converts a high-level language to its equivalent machine language program. So here, just-in-time compiler, what it will do, it will convert the selected portion of the bytecode into executable code in real time. In real time means when your program will be executing, at that time GIT will convert some portion of the bytecode into its equivalent executable code. So how this is decided? Again, this will discuss in the coming classes. The main important point is entire Java program is not compiled by GIT. Only some pieces of your source code gets compiled by GIT, and that also on demand basis. So whenever uh, there is a requirement, the compiler decides about this, because every compiler has an optimization module that optimize your code. So wherever the code optimization is required, your JIT will be requested to convert only that portion of the bytecode into its equivalent executable code. So this is the important point. I repeat again. The JIT converts only the selected portion of your bytecode into the executable code, that also in real time. And again, the main is that conversion will be on demand basis. So this JIT will be requested to convert a particular portion into its equivalent executable code. So these are the some of the features of your Java language. It's a simple, secure, portable, object-oriented, robust, multi-threaded, architecture neutral, interpreted, high-performance, distributed, and dynamic programming language. And as we go into more detail of this Java programming language, we'll discuss all these points one by one in the coming lectures. So this is your first program that we are going to discuss in a little more detail. So the first important point is Java is a object-oriented programming language. So whenever you will write the program, that program will have at least one class. Right over here, I have shown this. This is the class that we are going to create. So if you have studied C++, that you might be aware of this. Whenever you want to create the class, we use the keyword first class, then the name of the class. So this name, class name is example. So in one of the Java classes, you will write the main method, as I have discussed with you earlier, that there can be any number of classes as per your requirement. So there is only one example class. Your program can have a number of classes. So in one of the classes, there should be a main method. So this is the method. In C or C++, we call methods as function, but in Java we use another word for functions, and that is method. So this is method, or we can say function. This is the name of the function, and this is its return type. Every function has some return type. So void is the return type of the function, name is the name of the function, and this function is public static. Public is the access specifier. Again, we will discuss these terms in more detail when we will discuss about classes and objects. So this is the access specifier. Two more are there, private and protected, but the main method should be public as well as static. So why we use this static word, again, we will discuss it soon. So for the time being, this main method should be public, static, and void. And to this method, will pass some string type arguments. And this string is basically a name of the class. This is a class name, inbuilt class name. args is the argument. Here this is not mandatory that you should always use agrs. You can use any other name. It can be a or x as well. So this is basically a string type array. So I will discuss in more detail about arrays in the coming classes as well. So this is string type array, and that means we can pass to this method some arguments. Right? We'll discuss how you can pass the arguments to the main in the coming classes as well. So within this method, you are supposed to write some code. Initially, we will be using this main only for some lectures, and how you can print a message in Java that I have shown over here. So this system is one of the inbuilt classes. The system is the class name. Out is a variable. So this variable is of print stream class. So it's the output stream class variable. And println is the name of the method. So this method is basically available in a class print stream. So this is the object, and this is the method of that class whose object is this. So println is basically prints the message, the string that you have passed it as an argument on your monitor screen. So this will print, this is a simple Java program on your monitor screen, right? So don't forget to end every statement that you will write inside the main method with semicolon. So the statements in Java are also separated by semicolon. So this is the separator. So this entire source code is called compilation unit. Some books used another word for this that is called Wora, W-O-R-A. Wora means write once, run any number of times. Wora, W-O-R-A. So again, the important points, when you will save this program, the program should be saved with extension in Java. Java is a case sensitive. Case sensitive, you know, still I'm going to repeat it, that in this language, it differentiates between uppercase and lowercase letters. So system, if we are using this command system.out.println, system's S must be capital. So keep in mind, if you type system in small, all in small case, it will not work. This S of system must be capital. Right. So this is the important part. So Java is a case sensitive language. So you have to type the commands that I have shown over here in the same case, either in lowercase, or if this is in uppercase, you have to put S in the uppercase only. Here's another example. In this example, we are basically discussing some simple statements. So although we'll discuss this line in more detail, but you have studied it in other languages also. Whenever you want to create a variable of type integer, you can use this line int num. Right? This is the variable name, and this is the data type that you all have studied it in C as well, or some of you might have studied Java as well. So this is the variable, and we will discuss it in more detail, how to declare the variable, how many bytes of memory is allocated for a variable of specific type, that we are going to discuss in the coming slides as well. The next line, we are assigning 100 to the variable num. Here we are using assignment operator. This equal to is basically called assignment operator. So this will assign 100 to variable num. Then we have used one system.out.println method to print the message on the screen. The message that we want to print is this is num, and then here it will display the value of the num variable, that is 100. So you will get this result. This is num colon 100. So how it will be executed, that I'm going to discuss with you in more detail. So whatever is there in the print statement, the first important point to notice is that if you want to print data of different type, for example, this is a string, anything that you enclose in double quotes is called a string literal. So this is a string literal that is in double quotes, and this is your integer variable. And if you want to separate two different types, then in case of Java, we use plus sign for that in println function. So what will happen, this plus is basically a concatenation operator, because it will work as a concatenation operator over here, because this operand of plus is string, another operand of plus is an integer value. So these two are of different type. So what the Java will do, Java will convert this num into string automatically. So it will convert the value of num into string. So this is 100, so it will get converted into string first. So then these two strings will be concatenated. So these two strings will be joined. So you will get, after concatenation, you will get this result. This is num 100, right? And then this println method will print that result. So I repeat, what will happen first, because the plus operator is there, one of the operands is string, other operand is integer. So Java will convert the integer operand into string, and then these two strings will be concatenated. After that, this println method will display the result, that is that string. Then the next line, here we have used arithmetic operator multiplication. So it will perform this operation, 100 into 2, 200, and that value 200 will be assigned to the variable num again. So this line is basically modifying the value of the num variable, and again we are printing this result. The value of the num into 2 is, but notice here that we have used print only. So what is the difference between print and println? So println basically outputs a new line character at the end of the string. So it will automatically add the new line. But in case of print, it will display the message on the same line. So you will get this message on the same line. The output number, the value of num into 2 is, then the next line result, that is num, will get print in the same line. So you will get this result in the same line. The value of num into 2 is 200. So this is what you are going to get. So this is another program. The crux of this program is, whenever you print any result with printf, first of all, that gets converted into string, and then that is printed. So this is what happens. So in this program, we have used over here one description over here. We have written a description of this line. This is basically the commands, and commands are basically the non-executable statements. These are ignored by the compiler. So what type of commands are available in Java, that we are going to discuss in the next slide. So there are three kinds of commands that are supported by the Java language. First one is single line commands. So if you want to put some commands or description of some line in the single line, then you can use this double forward slash, and after the double forward slash you can put the description. For example, over here I'm using the integer variable I, and I have put a description of this line over here. So this these comments are basically used to improve the understanding of the program. So these are single line comments. That means the comments can be of one line. Then the second type of comment is multi-line comments. So multi-line comments, as the name suggests, you can put the comments in multiple lines, and in this case your comment should start with the forward slash star and it should end with the star and forward slash. Whatever is there in between these two symbols, that will be treated as comments by the Java compiler, so that will be ignored. So another important point about multi-line comments is multi-line comments cannot be nested. You can't write one multi-line comment inside the another. So this is the important point. The third type of comments that are allowed in Java is doc comments. And doc type comment starts with slash double asterisk sign and ends with star and slash. So whatever you will put within these two symbols, that will be treated as doc comment by the Java compiler. So what is the benefit of doc comments? It basically, these are used to build the online documentation of your class. So I have shown one example over here for that. So it is starting with slash and forward slash and double star, forward slash and double star, and ending with star and forward slash. So whatever you will write in between these two will be treated as the comments. And in doc comments, you can use some special tags as well, like HTML tags can be used inside the documents. So here I'm using the TT tag of HTML. So another important point about comments is comments can appear in between the tokens. For example, over here, if you want to declare a num type variable, and here in this example, I have included comments between int and num. So it can be written between the tokens. So this is one token int and this num is another token, and I have written one comment inside these two. So next important point is if you write any comment within the double quotes, then that will be treated as a string literal. That will become the part of the string. Then comes some reserved word. Every language has some keywords. Those keywords are called reserved words. Reserved word means that those words cannot be used as identifiers in the language. So these are some of the reserved word: abstract, const, double, go to, if, null, right? These you know very well because you are already aware of C, and some of you are also aware of this Java language as well. So in Java, basically two naming conventions are used. This is very important to understand. First one is camel casing. Camel casing is basically used to name the variables, and camel case is basically, it's a rule, and in this rule every word of the variable should have first letter capital except the first word. So if I use a variable having two or more than two words, then the first word should be in all small letters, and second word onward, every word should have their first letter capital. So that is called camel casing. Then the second is Pascal casing. In case this naming convention is used to name the classes. All the Java inbuilt classes are named using this naming convention, Pascal convention, and according to this naming convention, naming norms, every word should have their first letter capital. For example, if the class name is array index out of bounds, so array is one word. This is the complete name of the class, array index out of bounds. So a of the first word array should be capital, right? Of array index I should be capital, out O should be capital, of O should be capital, bounds B should be capital. So if the class name is array index out of bounds, this is just you have to use this all these words as a one word. So this is the rule. I will show you that in Eclipse also. So let me show one example to you regarding this.
This conference will now be recorded.
So here you will declare some variables, right? I have created three variables A, B, and C. Assign some value to variable A, let's say 23, and some value to variable B, let's say 34. B is equal to 34. Then write the statement. If you want to add, you have to write A plus B. This you know very well. This is another operator, arithmetic operator, plus. And after that, we want to print this. So you have to use system, then out. So see over here, this out is basically is an object of or instance of print stream class. So this is print stream class object. This class is basically of final type. So this is final class. What is its meaning we'll discuss later on. Then there is a method println. So in this method, if I want to display the result like this, a value of A, then I want to put a plus symbol. After that, I want the value of B. Then I want to print equal to sign. Then I want to print equal to sign. And after that, I want to get value of C. So what it will give me? It will give me 23. So this A will be replaced by its value 23, and then you will get plus sign. After that, the value of B 34, then equal to sign, and then the value of A plus B. So let's run it by clicking over this option. So here is the result: 23 plus 34 is equal to 57, right? So this is the program in Eclipse. Now let me show you how to run a Java program using Notepad, right? So how you can do that? I'm going to write over here cmd to switch to the command prompt, right? This will open the command window. So this is your command window. In this command window, I will type this command cd/ to switch to the root directory, that is C directory. In C directory, I have one directory named program files. In program files, I have another directory Java. Open that as well. Then in Java, we have one directory JDK 1.8.0. So open this as well using CD. In this directory, we have one folder or directory bin. Open that. And here we have all the files of Java. So Java, I'm going to show you all the files starting with the J word. Oh, sorry, starting with alphabet J. So these all are the files. So here is your Java compiler and the Java that you use to run the program. So what you will do, if you want to write a program in Notepad, you will type over here Notepad, then name of the program that you want to create. So I want to create the program name he. This is the name of the program, he.java. So it's giving one message, can't find the file this. Do you want to create a new one? Yes, we want to create a new one. So in this window, you will type class, then a name. Name should be same as that of your file name, right? So this is Java. And over here, you have to write inside this public static void main. This is the name of the method, and to this method you have to pass string type argument. It can be any name, it's not compulsory. So I'm using s as a name over here. And within this method, you will use some code. So for the time being, I am going to show you how to print hello in it. So this is the complete program, right? Now save it, save this program, right? Go to your command window over here and type over here Java C and then name of the program he.java. If this program is fine, then after some time it will show you the command prompt again. So that means there is no error in this program he.java. So when you compile it, it will create a class file. Let's check that. See the file starting with he. See here. When you will check all the files starting with he, it's listing two files over here. One is he.java. This is your source file, and another is he.class that you have just created with the Java compiler. When you will compile it, it will create this file. So he.java is the name of the class. Now if you want to run the program, type Java and then the name of the class file he. So you will get the message or the result in the next line as shown over here. Now let's check if you change the name of the file over here, name of the class file. Let's say its name is Ashok, right? I have changed the name of the class to Ashok, but name of the file is still he. So see what will happen. Now if you compile it, Java C file name is he.java. So here you type the name of the file, and name of the file is still the same, he.java. So run it. So now it has created a class file. Let's check what is the name of the class file. So you will be surprised to see that the Java creates a class file whose name is same as that of your class name. So class name was class name was Ashok. So it has created the file Ashok.class. It hasn't created the file he.class. It will create a class file whose name is same as that of your class file. So class name is Ashok. That's why it has created over here the Ashok.class file. So now if you want to run it, you have to type Java Ashok, because name of the class file is Ashok. So you will write over here Java Ashok. You will not type over here Java he, right? So when you will type Java Ashok, you will get this result. So as we discussed earlier, the name of the file and name of the class should be same, but this is not compulsory. Name of the file can be different from your class name. If these are two different names, then the Java compiler will create a bytecode file whose name will be that of the class name. So this is the important point. Uh, I hope you don't have any doubt. If there is any doubt, you can ask. Right? Is there any doubt?
This conference will now be recorded.
Now we are going to discuss about literals. So literal is basically a constant. Some books use this word also, constant or literal, both are the same. Constant means any entity whose value cannot change during the execution of the program. So there are many kinds of literals in Java. The first one is integer literal. So any whole number, like I have shown over here, 1, or you can take another example, 12, 1024. So whole number, those are the integer literals, right? So integer can be of type long as well, that we will discuss in the coming slides. So if your literal is of long type, then you can add the suffix l with it. Suffix l can be a small l or capital L. So one L is basically here, the one is a long type literal, and this one is an integer type literal. Similarly, another example is 1.0. So this is a floating point literal. So we'll discuss by default all the fraction numbers are of type double in Java. So this is basically a double literal 1.0 or 1.62. That is also a double type literal. Then any alphabet or symbol or digit, if you include that in single quote, that is treated as a character literal. So this is the example of character literal, and this one is the example of string literal, a collection of symbols or alphabet or numbers. If you include that in the double quotes, then that is treated as a string literal. So this true is basically a Boolean literal, false is also the Boolean literal, and null is a reference literal. So we are going to discuss the literals in more detail in the coming slides. So first is about punctuation. Java uses some punctuation symbols. Uh, These punctuation symbols are divided into two categories. The first category is separators. These separators are 12 in number. So the examples of separators are like semicolon that you use at the end of every Java statement. Then parentheses are there, braces are there, square brackets, colon, right, dot. All these are the punctuation separators. Other type of punctuation symbols are called operators. So we will discuss all these operators in more detail in the coming lectures. So plus, minus, multiply, divide, modulus, so these are all the arithmetic operators that we will discuss in more detail in the coming lectures. Then bitwise operators are there, relational operators are there, right? So, so the next slide is about the primitive data types. So under this category, we have 8 basic data types. And these basic data types are data byte, short, integer, long, character, float, and double. Some books call these primitive data type as the fundamental data type or basic data type as well. Under the integer category, we have 4 types: byte, short, integer, and log. And the float type data type, we have 2 categories: float and double. And so total 8 are there. So one by one we are going to discuss all those. The first one is this slide we will discuss later on. Integers. So for integers, there are 4 types of integers that you can use in Java language. The first one is long, and for long, 8 bytes of memory is allocated. So this, if you declare a variable of this type, then you can store a number between this and this that I have shown over here. And if you are using the integer variable, for integer, the 4 bytes of memory is allocated, and the integer variable can store a value between this and this range. Similarly, for short, 2 bytes of memory is allocated, and for byte type variable, 1 byte of memory is allocated. So I have shown the width in number of bits, right? So for byte, 1 byte of memory is allocated, and this byte type variable can store any value between 128 negative to 127 positive. So most important point about Java integers is the Java integers are signed numbers. You can't use unsigned numbers in Java. So every time you declare a variable, that variable can store or will be able to store a negative or the positive number. Unlike the C, you can declare unsigned variables also, the variable that can store only the positive value. So this is the important point. So I repeat, for long, 8 bytes of memory is allocated, for integer 4 bytes, for short 2 bytes of memory is allocated, and for byte type 1 byte of memory is allocated. Then comes floating point data type. We have 2 data types under this category. One is float. If you use float, then 4 bytes of memory is allocated, and the float type variable if you declare that variable in your program, that can store any number between this range, this to this range. So E over here represents 10 raised to power minus 45, 1.4 into 10 raised to power minus 45, to 3.4 into 10 raised to power 38. So this is the range of the floating type number. And if you use a double type variable, then that variable will be allocated 64 bits or 8 bytes of memory, and that variable can store any value between this and this range. Then comes the character data type. For a character variable in Java, 2 bytes of memory is allocated, and a character variable is used to store any character. So basically in Java, the character is called Unicode characters. A Unicode character can store any symbol of any international language. How you can store any symbol of the international language, because whatever laptops or desktop you are using, those desktops have a limited number of keys, and if you want to represent any symbol like theta or alpha or beta or any other symbol, if you want to store that, then how you can store that, that we will discuss also. So for the important point over here is the character uses 2 bytes of memory, and the character range is from 0 to 65,536, because characters are basically treated as one of the integer type in Java or in some other languages as well. So the next data type is Boolean. The Boolean variable can take 2 values only, either true or false. And if any expression is evaluated, that also evaluates to either true or false. For example, over here, if we use this expression A is less than B, this expression will evaluate to true, Boolean value true, or the Boolean value false. Like unlike C, in C, if you evaluate this expression, this will evaluate to either 1 or 0. In C, in case of C or C++, the expression will be evaluated to 1 or 0. The output will be integer. But in case of Java, such kind of expressions evaluate to a Boolean value, that means either true or false. Then in the coming slides, we are going to discuss the literal in more detail. The first slide shows how you can represent integer literals. For example, in the first example, I have shown the decimal literals, numbers with 10 base 10, so 12 is a decimal literal, 3465 is a decimal literal, and this is a long number, and I have added suffix L to it. So that if you add suffix L, then that number will be treated as long integer, means for that system will allocate, you can say, 8 bytes of memory. And if I add L to 12, then this 12 will become the long integer literal. Your integer literal can be represented in octal also, and if the literal is in octal, then you will start with it 0. So 0, 1 is the octal literal. This is the rule. The number that you want to represent in octal should have a prefix 0. So here 2, 2, 3, 4 is in octal, right? And if you want to represent a number in hexadecimal, then you will put 0x before the number. So this 0x 2a6. So 2a6 is basically a hexadecimal number. Similarly, 2a6 is a hexadecimal number. So please note that either you can use capital letters or lowercase letters for the hexadecimal hexadecimal symbols A to F that you know. Here I am using capital X. So 0x, X can be small or X can be capital. So in these two examples, I have used small x, but in this example, I'm using the capital 0 and X. So this 23EF is a hexadecimal number. Similarly, if you want to represent a long hexadecimal number, then you can attach a suffix al to it. So this is for that. If you want to represent a binary number, then you can use prefix 0b, small b, or 0 capital B. After that, you can write any number like 0b 001 or 1001, right? So that will be treated as a binary number. And another example I have shown over here. This is another example. You can even separate the digits with the underscore as well. So 0b indicates that this is the binary number. So the binary number is 1101. This is a one single number, but if you want to separate the digits for clarity, you can add the underscore in between. So this is the same thing I have used for the integer number. So this is one long number, and I have used some underscore in it to improve the readability of the number. So shall I show some examples using.
This conference will now be recorded.
I'm going to show you example on floating point numbers. So A, B, C are the floating type numbers, and I want to assign the value 23,101. Sorry, this should be underscore 23,101 dot 23. This number is 23,101.23. Fine. And the second number is, let's say it is 2,301 dot 1 underscore 2. So the second number is I've shown you here, right? And if you run it, you will get this result. See here, right? So you can use underscore anywhere in the number, right, to improve the readability of the number, but the underscore cannot be used at the end. So if I use the underscore here, this is wrong, right? This will not compile. Or if I use the underscore in the beginning of the number, that is also wrong, right? So both the statements are wrong. So underscore have to be located within the digits. So this is the important point. So let's now discuss the next slide. I think it's clear to you now.
This conference will now be recorded.
So similarly, for floating point representation, you can use standard notation. There is two types of notation for representing a floating point number. In the standard notation, we use decimal point, and after that some decimal digits like 3.14159. So this is a standard notation. Another example, 0.6667, right? This I have already discussed with you. This is 9,423.109. And in scientific notation, we use this E for the exponent. This number is 6.022 10 raised to power 23. So this E indicates 10 raised to power the next. This is the exponent, and this is the base, or sometimes we call it mantissa. So this is mantissa and this is the exponent. So over here the number is 31,400 no, it's bigger than that. 3,14,159 into 10 raised to power 05. I think you got it. So this important point is again any number that you write a floating point number is treated as double. So this 2.0 is basically a double number. It's not floating point, right? Float. It's not float because we have two data types in Java. One is float, other is double. So any fractional number is by default double. So this is double. This is double. If you explicitly want to mention that this 2.0 should be treated as float, then you have to add suffix f to the number. So use f, capital F or small f to instruct the compiler, Java compiler, that the number is a float number. And if you explicitly want to mention that this number is double, then you can at the end of the number you can add either capital D or small d, and that will instruct the compiler that that number is a double number. Similarly, in floating point number, you can use the hexadecimal notation, and for that number should proceed with 0x, and then you have to write like this: 12.2 p to p. Here this is called binary exponent, right? So for 10 raised to power something we use e, for 2 raised to power something we use p. So this is 2 raised to power 2. To represent a character. For example, if you put /141, so exactly after the slash, if you use 3 digits, then that number is treated as the octal number. So if you convert this 141 octal number into decimal, you will get 97. So that is equivalent to A. So the code for 97 is A. Sky code for A, we can say it's 97. So 141, it's in octal, and its equivalent number is 97, and 97 is the code for small a. So that's why this is A, right? And if you want to represent any other number, you can use this notation as well. Let's suppose if you want to represent capital A, then you will write 041, right? 041. So 041 is basically 65, and 65 is capital A. So you can use octal notation to represent a character, and for that you will include in the single quote slash and then the 3-digit octal number. Then if you want to use the hexadecimal notation to represent a character, then you will use /u, and after that 4 digits, and those 4 digits will be treated as a hexadecimal equivalent. So 0063, this means this is the hexadecimal code for the character. So if you convert it hexadecimal, if you convert this to convert this to a decimal, then you will get the result 90. You will get 96 plus 399, and 99 is equivalent to C. So here in this case, if you put 141, the conversion, octal to decimal, you will write the first digit 1 into 10 raised to power 0, 8 raised to power 0, then plus second digit into 8 raised to power 1, plus third digit 1 into 8 raised to power 2. So this way you convert it and you will get the result 97. Okay? And if you want to represent capital A, as we discussed earlier, your number should be converted to 65. So how you will get 65? It should be 101. Earlier I told you 041. It should be, I think, 101. 101 will get converted into 65, and in that case you will get the capital letter A. So this is the escape sequence. This you already know. You have already studied in C as well. So if you want to break the line, you can use the \n new line character. And if you want to leave a space, you can use number of spaces, 8 spaces by default. You can use tab. Similarly, backspace, it removes the previous character. Form feed, it will print the symbol the beginning of the next page. This is basically used while you are printing something, because this form feed prints the output in the next line. And beginning next page, beginning of the next page, this form feed. Carriage return prints that symbol in the beginning of the same line. And this one is, if you want to print the double quotes, then you have to use / double quotes. If you want to print / only, you have to use /. These two we have already discussed: TDD, octal representation, hexadecimal representation. And if you want to print the single quotes, then you can use single quote as well. So now the thing is, shall I?
This conference will now be recorded.
This slide is basically on string literal. So anything you enclose in double quotes is treated as a string literal. For example, here hello world is a string literal, and even you can include the escape sequence symbols in the strings as well. So this 2 lines is basically, there is \n. So when you will print this string literal, you will get the output in 2 different lines. Similarly, the next line, this is in quotes, you will get this is in quotes, in double quotes, right? So you will get this message that I have shown over here in double quotes. So the next thing is identifier. Identifier, basically some languages use the name variable for this. So identifier is the name that you give to any variable, or to a class, or to enumeration, or to a package, right? So that is called identifier. So there are some rules that you have to follow while you name the identifier. So the first thing that is important is identifier may be of any length in Java. So it's not limited. Next is, it should contain letters and digits. It should begin, the next rule is identifier should begin with the alphabet, or it can begin with underscore, or some other symbols are allowed, like $sign is allowed, and some Unicode symbols are also allowed in the identifier name. Generally, we don't use $sign because the Java itself generates some internal variables, and those internal variables are basically start with $sign. So we don't use, even we can use it, but it's recommended that we shouldn't use $sign as the first symbol of the variable name. So how you declare the variable? First we write the data type, and then the variable name or identifier name. After that, some value that is optional. The optional part is shown in the square bracket, and if you want to declare more than one variable with the same within the same declaration statement, then you can use comma separator and put the next variable there in the same line. For example, over here I have declared three variables in the same line, so A, B, C are of type int. So this is called the variable declaration. And in the second line, I'm declaring the variable and assigning some value to the variable. So this is called initialization. So there is a difference between declaration and initialization. So declaration means just declaring variable, uh, and initialization means assigning some value to the variable while it is being declared. So declaring and assigning in the same step is called initialization. So this is initialization, and this one is also initialization. Similarly, a byte type variable is being initialized in the next line. So there is a variable z, and we are assigning value this type. And in the next line, we are initializing a double type variable pi with this value. And the next line is initializing variable x with the character literal x. So then comes the dynamic initialization. So what's the difference between initialization and dynamic initialization that we have discussed in this slide? So if you just this line, as we discussed earlier, double R, this is just a declaration. If we write here R is equal to 2.23.45, this is assignment, right? If I put over here like this line, double pi is equal to this is initialization, means assigning some constant to a variable when while the variable is being declared. That is called initialization. And dynamic initialization is if you are assigning value of an expression to the variable that is being declared. So we are declaring the variable area, and in the same line we are assigning it the value of some expression. So this is the example of the dynamic initialization. Dynamic initialization, I repeat, it's if you assign the value of an expression to the variable when you are declaring a variable, that is called dynamic initialization. So the next is type conversion or type casting. So there are two types of conversion. One is called implicit conversion, other one is called explicit. So for the first category, some books also use this word automatic conversion. I'm going to show you some examples for this conversion.
This conference will now be recorded.
I'm going to show you some examples on implicit and explicit conversion. So here if I use the word float, right? Now A, B, and let me use only one variable, A. So variable A, I have declared it of a type float. If I assign it value to 23.25, right, and print it using print statement. So here is the print statement. I'm printing it. Let's compile it, run it. Okay, see, if you try to run this program, you will get this error exists in the required objects, right? This is the error you are getting. If I proceed, then it's showing me, see this message, type mismatch, cannot convert from double to float. As we discussed earlier, a floating type number is treated as double by default. So the left hand side variable is of type float, right hand side value is of type double, and computer your compiler is Java compiler is not converting a double into a float automatically because the double has a higher range than the float, right? So any data type that has higher range than the destination type not gets converted automatically. So here the Java is not converting it this double to F automatically. So you have to use uh, F as a suffix, then it will work because F will basically make it a float, right? As we discussed earlier, you have to add suffix F, then this will instruct the compiler that this is a floating number and we are assigning it to A. Now it will work. Okay. This is the one way if you want to get the solution, right? So we discussed also you can use either capital F or small f, right? So now if I try another example, if I make it of type double or float, sorry, let it remain float. Now it will not complain. Now your program will work. Why it is working? Because on the right hand side we have integer number. On the left hand side we have floating point variable, and Java is automatically converting this integer number to float, right? Before assigning the value to A, here the Java is converting integer to the float. So whenever the Java converts one type of data to another, then that is called implicit casting or implicit conversion or automatic conversion. So Java is performing implicit conversion over here. It is converting integer to the type float, right? So any doubt, because time is about to